Energy is discussed in Chapter 5, but for whatever reason, they set a small section here in Chapter 1. So I will keep it very simple. We just want to distinguish between kinetic energy, which is the energy of motion, and potential energy, which is the energy of position. So the easiest way to think about it is to think about a person on a bike at the top of a hill. They have a high potential energy and a zero kinetic energy. As they begin to go downhill, they have decreasing potential energy and increasing kinetic energy. So where does this fit in? Well, in Chapter 10, we'll learn about internal energy. But in Chapter 1, they just want to say, what is energy? It's the capacity to do work or to transfer heat. So what is work? Work occurs when energy is transferred. There is a force that is exerted on an object that causes displacement. Think of it more in a physics term. What is heat? Well, heat is the energy used to increase the temperature of an object. I'm going to leave it at that until we get to Chapter 5. Now, the reason there is a problem here is because back in Fall 18 on Midterm 1, this problem was given in an exam. And it said, calculate the kinetic energy of an electron. It gave you the mass and it gave you the speed. Well, the formula for kinetic energy is Ke equals 1/2 mv squared. So I'm going to work this now. I don't expect you to work this today, but let's say by the time Midterm 1 comes around, you would have enough background to carry through. This is really a dimension analysis problem, and we will be doing that at the end of this chapter. So I've put in the mass 9.11 times 10 to the minus 28 grams. And notice, energy is measured in joules, and joules has the unit of kilograms. So what we need to do is convert our energy in grams to kilograms by using a conversion factor. Then what we will do is put in a speed. 6.00 times 10 to the 6th meters per second, and we will square that because it's 1/2 mv squared. Now, to keep this simple, I am just going to do the conversion of units in the exact same line. And again, by the time you get to Midterm 1, this will not be an issue, but it is an issue today. So I'll punch the numbers into my calculator and I'll come up with the answer 1.63 times 10 to the minus 19 joules. Now, when I wrote my own exams, I did not put a question like this in my exam. When we moved to common exams, these questions started to appear. Therefore, to be fair, I needed to put the question and insert it here into Chapter 1. The second thing to talk about here is the scientific method. And you've seen it before, collect your information, formulate a hypothesis, test the hypothesis, formulate a theory. So let's make it simple, okay? Your cell phone is not going to turn on. So the hypothesis you could make is the battery is dead. The experiment you could do is plug in the charger. The observation you may make is the battery light turns on. So you can relate to this example. The conclusion you could come to is the battery is dead and it needs time to recharge. But, and this is the big but, maybe you've experienced this. Does this mean the phone will work now? So there's a lot of articles in the literature where it says, people publish positive results, but negative results, when you're a scientist, they also help you learn things. So that's why I'm forcing, really saying, let's do insight in this class. We can know what the scientific method is, but let's say we got to this conclusion. The battery was dead, it needed time to recharge, our phone should work, but what if it doesn't work? That's like a negative result, and you would have to do some problem solving in order to figure out what's going on, okay? The other section in this chapter is section 1.5 called Units of Measurement. So I'm going to draw your attention here to this picture I put in. I have a new grandson and someone gave him a board book. You know, we're all scientists in our family, so of course there will be nerdy books. And the letter U stands for units. It could be for measurements, meters, yards, or feet. So that is a qualitative measurement. You know, what is the measurement? What is the length? What is going on? And a qualitative measurement is either the presence or the absence. In our course, we will be doing quantitative measurements. By that I mean it's a measured quantity. You will be obtaining data, and it could be a mass, a volume, a length, or a temperature, and you will measure that quantity. So what I posted here is things you might be interested in. If you're a biotype major, well, there are the centimeters, millimeters, micrometers, nanometers, the metric conversion factors that we have in an earlier section of the course chapter. And what we want to do is show you plant cells, how big is a bacterium, how big is a virus, how big is a small molecule. These are all important later in your career, but we are the intro chapter. The other thing to draw your attention to is this is a cotton ball, okay? And you could look at it, but as you put it under a microscope, you could see it magnified, and if you could magnify it all the way, what you could do is take it down to the atomic level where you would have spheres that represent different atoms. Much like the pictures back in section 1.2 where we talked about molecules like carbon dioxide. So again, we need to learn the units of measurement so we can measure things. What do we have? Well, we need for you to memorize these metric units. It is not fun. It is just a pain in the neck. But essentially, these are the ones to really know, the ones I put the check marks in front of. Kilo, as in kilometers or kilogram, all the way to nano, which is 10 to the minus 9. In the later section of this chapter, we're going to be using dimension analysis, but they separated it out here. Again, please do the homework that's on the beginning of this section. Please ask questions. I want you to have a firm foundation, and that happens when you ask questions right from the beginning. Also know there's no such thing as a stupid question.